My name is Adrian Hughes and I head up the GIS team at RSPB, and today I'm going to talk about how we're using GIS to help our conservation work. So first of all, I just want to tell you a bit about the RSPB, the Royal Society for the Protection of Birds. We're Europe's largest conservation charity and we own and manage over 200 nature reserves across the UK. We have over 1.2 million members and over 18,000 volunteers. We engage with development work to improve outcomes for wildlife. We conduct investigations into wildlife crime. We're a science-led organisation and we run numerous research projects in the UK and overseas. We also advocate for wildlife-friendly policy in the UK and the EU. First off, I'd like to talk about our Gola Rainforest camera trap project, which we ran last year. The Gola Rainforest represents the largest remnants of Upper Guinean tropical rainforest left in Sierra Leone. It covers an area of nearly 700 square kilometres and is home to over 330 species of bird. A variety of other flagship species are also found in Gola, including the elusive pygmy hippo, threatened with extinction and only present in this part of Africa, an estimated population of 300 chimpanzees, and 49 species of larger mammals. This area is now recognised as a global biodiversity hotspot, requiring utmost effort and attention from the conservation community. Camera traps offer the opportunity to inexpensively and unobtrusively gather vast amounts of data on animals in the wild. Camera traps are particularly useful in a forest environment, where animals tend to be secretive in nature and the sheer density of vegetation makes it difficult to see anything further than a few metres away. This map shows the ever-growing network of camera traps in the park. The RSPB is collecting camera trap data from the Gola Rainforest National Park since 2008. These data can be combined with other data from surveys and patrols to understand presence and abundance of fauna species within the forest. This allows us to target conservation activities in the right places. Here we have a flavour of some of the species we can capture on camera in the park. Chimpanzees, the elusive and endangered pygmy hippo, Gentix dica, a species of antelope that was not thought to exist in the park until caught on camera in 2008, and also in the bottom right, the Diana monkey. By analysing the camera trap data, we can build up an idea of the species present within the park, but there is a resource problem with so much data. It can take a very long time to manually label tens of thousands of camera trap images. This time could be better spent on other activities and also results in lots of images remaining unlabeled and of no conservation value. We began discussions with Microsoft on how artificial intelligence, more specifically machine learning, could help us process all these data. We applied for a Microsoft AI for Earth grant, which gave us access to resources and experts to help us use machine learning models to detect and classify animals in imagery. There are two types of machine learning model that we use, the detector and the classifier. The detector, as seen in this example showing an African river hog, works at a coarse scale and determines if an image contains an animal, a human, or nothing. The detection results are integrated with image labeling software to quickly label the images. Once labeled, only the images identified as containing an animal need to be examined by species experts. Less time is wasted by looking at images without animals. We can also easily delete images containing people, which is important for data protection. The classifier works at a finer scale and attempts to identify species in the image. In this example, you can see the algorithm has incorrectly labeled the chimpanzee in the center of the image as another primate species, the sooty mangibe. Interestingly, the more obscure chimpanzee to the left has been labeled correctly. Species classification is more challenging and the accuracy is not as high as the detector. We hope to raise the accuracy by training the classifier with more images, and Microsoft are currently working on integrating the classifier with the image labeling software. In the not too distant future, fully automated species classification should be possible. Here's another example of the classifier working better this time in identifying the sooty mangibe. Okay, so you're probably thinking, where's GIS? Once we have these images labeled correctly, we can then look at the spatial distribution of the data. Here we are using an ArcGIS Online web app, which shows the camera trap locations in the park. The species list updates as the map extent is changed. We can also filter camera trap locations on species captured using the filter controls. Our eventual aim is to try and go beyond simple species lists and use the camera trap data to build occupancy maps for species in the park. It's impossible to talk about GIS at RSPB without mentioning Merlin. Merlin is our internal conservation data portal. It has existed in various iterations since the 1990s. The current ArcGIS Enterprise version was released in 2011. Merlin is available to all RSPB staff, giving them access to basic GIS functionality and a wealth of internal and external datasets. We have around 600 distinct users each month interacting with over 12 million species records, 15,000 cases, and over 500,000 mapped features. Merlin is a business-critical application for the RSPB and is a vital part of our efforts to tackle wildlife crime, manage casework, and record and monitor conservation effort on our reserves. This slide shows data being recorded and features being mapped for an ecological management plan for our Otmore Reserve. This plan helps us record progress against agreed management targets such as number of breeding birds present and percentage of habitat restored. The Ordnance Survey base maps are provided by Esri as web services. We also use Merlin to manage risk on our reserves. Here we are capturing data on hazardous trees at the Lodge Reserve. In the future, we plan to integrate these workflows with mobile data collection apps such as Collector and Survey 123. Later in this webinar, you'll hear from Richard at Scottish Wildlife Trust, who has done just that. A powerful feature of Merlin is what we call user maps. Users can add a wealth of data to their maps, including web services from other organisations such as Natural England, Environment Agency, and Esri's Living Atlas. Users can also upload their own geographical data as shapefiles. These maps can then be shared with other staff at the RSPB. A key advantage of a large system like Merlin is the ability to produce reports across all our sites. For example, this interactive report, which shows species assemblages across all our reserves. Finally, I want to talk about our use of drones. There's been a huge explosion in the use of drones in all sectors in the last few years, and this has been reflected in our organisation too. Cheaper, ready-to-go, off-the-shelf consumer-grade models, along with great improvements in cameras, which are easily interchangeable with different types of sensors. There's also been a great improvement in software that can generate mapping products from drone data, such as Esri's Drone-to-Map application. This slide shows the workflow we use for adding drone imagery to Merlin. After the flight, the drone imagery is stitched together in Drone-to-Map to create a single aerial image, which is then published to ArcGIS Online as a map service, which can then be displayed in Merlin. For RSPB, by far the most common use for drones is to capture aerial imagery. Aerial imagery is hugely useful for staff wishing to monitor change at their sites. The image currently being displayed is of Heather Moorland on our largest reserve, Forsonard in Scotland. The advantage of drone imagery over satellite or plane-flown imagery is that we can fly the drone when we want below the clouds and get an even higher resolution of just a few centimeters per pixel. Alongside our workflow, we've produced a best practice document around drones for GIS, which contains all kinds of information on model types, flying protocols, wildlife disturbance, legal issues, etc. This document can be found on wildlabs.net, an online forum for technology in conservation. We'll be releasing an updated version of this document in the coming weeks. To give some context to my next two slides, I wanted to mention the important work we're doing around peatland restoration across the UK. Much of the UK peatland has been damaged and needs to be restored to maximise the ecosystem services it provided and to mitigate climate change through carbon sequestration. Another mapping product that Drone-to-Map can create for us from our data is a digital surface model, using a process called photogrammetry, where the overlapping images taken by the drone are used to produce a 3D model of the surface. We can then use tools in ArcGIS to produce a high-resolution hydrological network from this surface. These networks can help us manage water on our reserves to help restore peatland. Another area we're looking at is using image classification, again using ArcGIS tools to automatically generate habitat maps from the drone imagery. Here we use a machine learning process using segmentation and the support vector machine algorithm to associate pixel colors and textures from the drone image with habitats. The pink areas here show the bare peat areas. We can use these maps to set a baseline for the restoration work and quantitatively manage progress towards restoration targets. This is an image of a stone curlew, a rare summer visitor to southern and eastern England, which nests on bare ground. The nests can be difficult to find using traditional surveys. The image on the right is from a drone-mounted thermal camera. You can see the warm eggs on the nest clearly using this type of sensor. We would like to extend this type of work to other species. Cardiff University have pioneered work using thermal sensors to detect nightjars on the nest. Nightjars are a highly camouflage protected species. The results suggest that drones could make the task of surveying nightjars faster, easier, more accurate, more cost-effective, and importantly, with less disturbance. Bird surveys are a vital part of the work we do to monitor bird populations over time. This image shows cliffs at our Falshew Reserve in Scotland, where 200,000 seabirds come to breed in the summer months along these spectacular cliffs. As you can see, these cliffs are very linear and cannot be seen from the land. Previously, expensive boat surveys were required to count birds. Now we can simply drop a drone over the cliff and capture the cliffs more accurately and for a greatly reduced cost. Currently, the birds on these cliffs are being manually counted by experts, but we are now looking at using machine learning to carry out automated counts. A closer look shows the number of birds inhabiting these cliffs. There are 3 different species of bird on this cliff: kittiwakes, guillemots, and razorbill. Okay, this concludes my presentation. Thanks for listening, and also thanks to Esri for supporting our work.